now I will explain igcse thermal expansion. Okay, here I will explain about melting point, boiling point, and evaporation. Okay, then the factor affecting the rate of evaporation. Okay, first of all, they may ask you the definition. What is the definition of melting point? So I have written all the notes. The melting in which, what you will write, melting in which solid changes to liquid. Okay, what? Melting is a process in which solid changes to liquid. What? Melting is a process in which solid changes to liquid. Okay, what is a melting point? Okay, melting point, a fixed temperature at which a solid changes its state to liquid. What? A fixed temperature at which a solid changes, or you can say melt, a fixed temperature at which a solid changes or melt its state to liquid. Okay, again I am repeating, what is melting point? You will write is a fixed temperature at which a solid changes or melt, you can write, its state to liquid. Okay, and what about boiling? How you will define boiling? Process in which liquid changes to gas. What? Process in which liquid changes to gas. Okay, what is boiling point now? Boiling point is a fixed temperature at which liquid, here what I told you, solid changes to its state to liquid. Here liquid changes into a gas. What? Here a liquid changes into gas at standard atmospheric pressure. Okay, here what happened in melting point? A fixed temperature at which a solid changes its state to liquid. Here liquid changes into a gas. Okay, and you have to write this one as standard atmospheric pressure. Okay, here you will get 1 point. Now see this, solid. When you melt solid, it will change it to liquid, and when you boil a liquid, it will change it to gas. Okay, and solid. Now let's go back. Gas on condensation, it will form liquid, and on liquid on freezing or solidification, the process is called solidification. They may ask this question, what is the process called? This is called solidification, changes to solid. Okay, again I am repeating, solid, if you melt the solid, like if you melt ice, it will change to liquid. If you boil that liquid, it will change to gas, right? And gas, like if you condense the gas, it will change to liquid. If you freeze the liquid, it will change to again ice. Means reverse process. Okay, now see this one. Why does the temperature remain constant at melting and boiling? Why? Why does the temperature remain constant? This is very important question. They may ask for like 2 marks. Okay, so answer it. Answer is like, at melting point, temperature remain constant because all the heat energy is used up in breaking the bond between the molecule or doing work. What? At melting temperature, at melting temperature remain constant because all the heat energy is used up in breaking the bond between the molecule or doing work against. Okay, what you will say? Again I am repeating, at melting temperature remain constant because all the heat energy is used up in breaking the bond between the molecule or doing work against the I have written wait okay at melting temperature remain constant because all the heat energy is used up in breaking the bond between the molecule or doing work against the molecular force. Okay, and against the molecular force I have written in other page. Okay, let me show you. Okay, again I'm repeating this question. At melting temperature remain constant. Why? Because all the heat energy is used up in breaking the bond between the molecule or doing work against the molecular force. Okay, why the temperature remain constant? This is the reason the temperature remain constant. Okay, see this is the graph. This is temperature. Okay, this is solid. Okay, and this is when from solid to it melt. If it melt, it will change into liquid. Okay, then this is the boiling point. When it start boiling, okay, then it will change to gas. Okay, like when this one solid is changing to liquid. Okay, when solid is changing to liquid. Okay, this is the temperature graph. Okay, see, like I told you before, in melting, why temperature remain constant? Okay, again I'm repeating this. Why? Okay, again I'm repeating this. Why the temperature here it remain constant during melting? Okay, at melting temperature remain constant because all the heat energy is used up in breaking the bond between the molecule, okay, or doing work against the molecular force. Okay, why it remain constant? Because the energy, where is the energy used up in breaking the bond between the molecules? Okay, then why the temperature remain constant here? Okay, during boiling, because it remain constant because heat energy is used by the molecule. Okay, what happened? Heat energy is used by the molecule to break the intermolecular force between them. Okay, you know this one, like solid, for example, let me say ice. This is okay, ice. Then when it changes to liquid, the molecule become like this. Okay, right? Then we change it to gas, it will become like this. Okay, so the what I mean to say is this. Okay, what I mean to say is, in solid, like the intermolecular force are very strong. When it changes to liquid, okay, when it changes to liquid, like the bond, okay, the bond, to break this bond they need energy. Okay, that's why temperature remains constant, because the heat energy is used up in breaking this bond. Okay, then for this again it changes to gas. Why the temperature remain constant here also? Because when it boil, the heat energy is, where is the heat energy used up? Heat energy is used up by the molecule to break the intermolecular force Okay, between this molecule, okay, between this molecule there are intermolecular force, I told you before. Okay, there are what? Intermolecular force. To break this bond they use the heat energy. That's why temperature remain constant. They may ask you why the temperature remain constant in boiling or melting. In melting, you are right this statement, like why it remain constant, because the heat energy is used up in breaking the bond between the molecules. This is the reason you will write. Okay, here they may ask you what happened energy conversion. The potential energy is changed into kinetic energy, you know. Potential energy of the molecule is changed into kinetic energy. Okay, again I'm repeating, they will ask you, this is the main point, they will ask you this, why the temperature remain constant during melting or boiling. You will write this. They use up in melting at melting temperature remain constant because all the heat energy is used up in breaking the bond between the molecules. Okay, okay, now let me explain you evaporation. Okay, what is evaporation? It is a process in which liquid changes to gas. What? It is a process in which liquid changes to gas. Okay, then at range of temperature below boiling point. What? At range of temperature below boiling point. What do you write? Evaporation is a process in which liquid changes to gas. What? Liquid will change it to gas. Okay, at range of temperature below the boiling point. Below the bond, before I told you that chart. Where is the chart? This one, this graph. Okay, okay, evaporation happen before the boiling point. Okay, before the boiling point, evaporate. Okay, I mean not before, I mean below the boiling point, sorry. Below the boiling point, the evaporation happen. Below the boiling point, evaporation happen. Okay, what you will write if they ask you the evaporation? It is a process in which liquid changes to gas at range of temperature below the boiling point. Okay, this one you have to write, this one. Okay, now evaporation and boiling point. Okay, range of temperature for evaporation, what you write is a range of temperature below the boiling point. Okay, it happen in fixed temperature. What? Boiling point, it happen in fixed temperature. Okay, and it take the heat from the surrounding. Evaporation take heat from where? Surrounding. And boiling, it need a heat source. Like you have to provide a heat source, like for example sun, or not sun, sorry, you have to provide heat like fire. Okay, and evaporation, it take the heat from surrounding. Okay, and it is a slow process, and this is a fast process. It take the heat from fire or somewhere source. Okay, and it is very fast process. Okay, no bubbles are formed here. No bubbles, you know, in evaporation no bubbles are formed, right? When the water evaporate from the sea, the bubbles are formed? No, it just evaporate. Okay, okay, and when water boil, like when water boil in a heater, Okay, you see the bubble, definitely bubbles are formed. And surface phenomena means at the surface evaporation happen at the surface, right? And this entire liquid, it happen entire liquid. The boiling happen entire liquid. When you boil water in the when you boil water, like the bubbler form, right? Bubbler form at entire. Okay, it happen in the entire liquid. Okay, and here at the surface phenomena means evaporation means at the surface of the sea, or if evaporation happen at the surface of sea or somewhere. Evaporation means the water goes up. Okay, like high energetic molecule means the very strong molecules or very powerful molecule at the surface. Okay, at the surface escape, and less energetic means less strong molecules are left behind, so the temperature decrease, and the temperature will decrease. The whatever water are left, the temperature will decrease. And you can say evaporation is a cooling process. If like water evaporate from after taking shower, like why you feel cold when water evaporated from your body? Okay, when the water evaporate from your body, okay, after taking shower, why you feel cold? Because the high energetic molecule, it evaporate. Okay, when the molecule evaporate, less energetic molecule are left. Okay, then those molecule, okay, those molecule which are left behind will decrease the temperature. That's why you feel cold. That's why evaporation is called cooling effect. Okay, this is the point you have to write when they will ask you like why evaporation is a cooling process. This is the thing you have to write. High energetic molecule, because the high energetic molecule from the surface escape and less energetic molecule are left behind, so temperature decreases. Okay, and difference between evaporation and boiling point, you have to write this one. Range of temperature below, it happen at the range of temperature below boiling point, or it's a fixed temperature. Boiling point, it will happen, water will boil at 100 degree only. Okay, it will not boil below 100 degree. When it will reach temperature of 100 degree, it will boil. Okay, and bubble form. Okay, it need heat energy. You know that it need electricity, like in or fire, or it is a fast process. Okay, and as you know, when it boil, the whole, like the temperature of it happen like in boiling, it happen all entire liquid through entire liquid. And this one, it happen at the surface, like it happen at the surface, the molecule at the surface which are having high energetic molecule. Okay, you can say high energetic molecule, it will escape first, and the less energetic molecule will escape later when it will gain more heat energy. Okay, factor affecting rate of evaporation. Okay, what are the factor, they will ask you. These are the points you can write. Increase the temperature or blow the air. If you blow the air, evaporation happen very fast. Or increase the temperature, or increase the surface area, or reduce the humidity, or reduce the pressure. Okay, these are the point you will write. Okay, what is thermal expansion? Okay, thermal expansion, okay, is in solid. It happen in solid, liquid, also in gas, but where it happen more is in gas. Like thermal expansion means if you provide heat, or like in railway, the red line in it expand. Why it expand? Like when the temperature is high, it expand. Okay, why? Because the molecule, as I told you before, because the molecule expand. Why it expand? Because the molecule expand, and it happen more in gas. Why it happen more in gas? Like if you provide heat energy in solid, liquid, gas, like same heat energy in solid, liquid, gas, but the gas molecule will expand more. Why? Because you know that already, like gas molecule, the intermolecular force between a gas molecule, they are far apart. Okay, why it happen more? Because gas will expand more because it does not have any intermolecular force. Sorry, it does not have any intermolecular force. That's why it will expand fast. Okay, so as their molecules are far apart from each other, it will expand more. Why? Again I'm repeating, why gas molecule will expand more? Because it does not have any intermolecular force between them. That's why it will expand more. And in liquid, because this the intermolecular force is very less, that's why it will expand less. Okay, and in solid only it expand little bit. Okay, not so much. In solid it expand little bit. Okay, and these are the thing like anomalous behavior of water. Okay, like water is changed into ice, right? The molecule expand and volume increases and it get frozen. Okay, one more point you have to remember is solid expand on heating and contract on cooling. What? Solid expand on heating and contract on cooling. Okay, if you learn this point, you are perfect. I mean, learn this point, like you can solve all the paper, but learn very well. Whatever point I have given, learn very well. Okay, bimetallic strip. Okay, what is bimetallic strip? It means it will consist of two metal, iron and copper. Copper expand more than iron. Okay, here this uses our burglar alarm bimetallic thermometer, where it is used for burglar alarm and bimetallic thermometer. Okay, again I'm saying learn all the point I have given you, like melting point, boiling point, changes solid to liquid, liquid to gas. Okay, they will ask you why does the temperature remain constant at boiling point, melting and boiling point. You will write this point, and this is the graph. They may ask you question from this graph. Okay, and evaporation, definition of evaporation, difference between evaporation and boiling point, and evaporation, where it happen. Okay, and factor affecting the rate of evaporation, you know, increase in the temperature. If you increase the temperature, like the evaporation will be more. If you blow more air, why the hair dry? Like why the hair dry? If you are using hair dryer, you are using air, right? So why your hair get dry very fast? Because you are blowing air. Or increase in the surface area, or reduce the humidity, reduce the pressure. This you learn. Okay, that's for and bimetallic strip, they will ask you the uses of this. Okay, thank you.